You are welcome to National VEX Robotics Training Competition, and I hope that you find this training engaging, and I hope you're going to enjoy everything about this training. So we need to wait. I don't think we need to wait for anybody again. So why we decide to do it on YouTube is so that at any point in time you can go back to the video and watch it. Okay, so I'm going to be sharing my slide with you. Why are we here today? Okay, so we are PiePixelz. We have collaborated with FCT-SEB, Secondary Education Board. No worry. We are partnered with a Secondary Education Board. We partner with Secondary Education Board and to bring this training to you. And we are VEX certified company, meaning that we have an understanding with VEX Robotics to bring this training to every schools in Nigeria. So our passion is to ensure that every student has first-hand knowledge on VEX Robotics. Okay, so it's beyond normal classroom activity. This is about the future of the children. It's about the future of the kid. And that's why we are here to train all students to engage in VEX Robotics. So our partner is, one of our partners is Bring It On Africa. It's an NGO. It's a non-governmental organization that is dedicated to empowering youth through education, innovation, and skill development. Please, if you have other NGO that can partner with us, feel free to share with us, because the goal is to ensure that all students have experience and knowledge on robotics. You agree with me that the world is changing, so we should change. You realize that what's it called now? The business world depends solely on people that technical savvy, people that have experience in technology. So it's not very important that we ensure that we make our students to be prepared for this future. It's very important that they are prepared for the future that we're preparing them. What's the importance of teaching students mathematics and English, sciences, without preparing them for the future that you're actually teaching them for? That is the goal. And you realize that the future that we're talking about is being taken over by AI, by robotics, by artificial intelligence, by technology. It's all about technology. It's not going to change. It's not going to change. It's always going to go forward. It's always going to go better. So it's now very important that we change our educational sector. It's very, very important that our educational sector, our curriculum, is being changed, is being geared towards ensuring technological driven. Okay, so this competition, I think I need to talk about this competition a little bit. As you can see, we are partnered with VEX Robotics, and I'll tell you what VEX Robotics is in the meantime. But I want to tell you what this competition is all about. It's about making sure that our students compete globally, internationally. They start with regional competition, then they step it up to international competition. Who is eligible for the competition? Any school in Nigeria is eligible, either public school, private school, even organizations that are interested can engage in this competition. But one thing you must ensure is that the students should be 5 or less than, depending on you. But I will encourage that make your student to be between 3 to 5. Okay, and age from 8 to 18, plus 1 teacher or mentor. So if you want, your school can register more than 1 team, but each team must be different. One student cannot belong to multiple teams. So if you're going to have 2 or more teams, make sure that you have different students for these different teams. And we have 3 categories of the competition. We have the elementary school, middle school, and high school. These are the 3 main categories of this competition. Or the elementary school division is for students of age 8 to 12. What that means is for children in primary school. So if your school is a primary school, you can engage in elementary school division competition. So what we're going to be using is the block-based code VEX Code VR platform. I'm going to be showing you shortly. the students are age 13 to 15, and what you're going to be doing is block code with introduction to Python programming. We are also going to be training you through these 5 days of training. You are going to be, if you're novice in this programming skill, we are going to bring you up to speed, and we're going to ensure that you are acquainted with everything about the programming. Okay, so, and the third category is the high school division, and it's for students from age 16 to 18. High school is senior secondary school. So elementary, primary school, middle school, junior secondary school, and high school, senior secondary school. Now for senior secondary school, they will engage in Python programming. Don't be scared. Don't be scared that me as a school leader, I don't know how to program in Python. That's why this training is for you, and it's 5 days training. It will equip you with what you need to do using Python programming, as well as block programming, and you can now cascade this training to your students. At any point in time you need help, you can always refer back to us. We can tailor any training for you that will help you, that will guide you, that will also help your students master during the course of this competition. Okay, so I need to talk about the competition challenge. Before I go ahead, I want you to like our channel, and I want you to comment, and I want you to share. Also, if you have any question, please write it down, put it in the comment section. We are going to attend to all your questions towards the end of this training. So write your question, write as many questions as you can, and we're going to answer every question. So what I've said so far is that this competition is for 3 categories: the elementary school, the middle school, and the high school. Now, what is the competition is all about? The competition is all about, 1, the maze solver. So what the student expected to do is to navigate their robot through a virtual maze that we're going to be introducing you to. They will use sensors. There was going to be sensors on the robot, and they're going to program the robot to navigate through the maze solver. The second task is disc mover. So the student will collect as many discs as possible and sort them according to colors. Don't be scared. Don't say, I don't know how to do all these things. That's why this training is for you. And as the students start exploring it over the year, we have experienced that students always get better when they do it themselves. So you allow them, just give them the task. They are going to ensure that they do it well. The third competition challenge is the castle crasher. The goal is to knock down walls efficiently within a time limit. So there's going to be a castle in the playground. It's going to be a playground. They're going to knock them down. Okay, and the fourth one is the treasure hunt, where hidden treasure will be located in some points on the playground, and the students will locate and find this treasure hunt. The last one is the coral reef cleanup. So what the student is supposed to do is to collect all waste objects in a river. So there's going to be a playground with a river, and the robots, the smart robots with sensors, you program the robot to collect as many waste as possible, and they're going to trash those wastes. Okay, now we also have a custom arena challenge. This is the secret for the finalists. So students that made it to final will be the one to engage on this custom arena challenge. So you should prepare intensely for the first 5 challenges, and the last one is going to be for the finalists. So you should take note of these key dates. Okay, so we already opened our entry on the 27th of October 2025, and if you've not registered, please, you have to do that, because that is the first requirement for you to be part of this competition. So submission deadline is 7th of December, and is a strict deadline. We don't want great cash out, so that we're able to prepare very well. Okay, so we also want you to know that the winners will be announced mid-December. It's going to be 2 weeks after deadline. We're going to announce the winner for the competition, and we're going to have the almighty national finals. I believe you're excited about that. Okay, so the national finals will be on 30th of January 2026. That will be the final, and I tell you, there are a lot of goodies to win. We have laptops for grab. We have a lot of goodies to be won. In short, you will love it. You will love it. So we believe that when you put effort, we don't want your effort to go into waste. Okay, so just to reinforce what I've said before, these are all the schedule. And if you've not joined the WhatsApp channel, I will advise you to check the comments section below. We have included a link to the WhatsApp and the link to the registration so that you can register your school in case you've not registered. Okay, so official announcement and school registration is the 27th of October. Our teacher and student orientation training is from 10th to 15th. That's 5 days. Today being the first day. And the submission of your coding project is from 1st to 7th of December. So after the training, your students are supposed to start immediately. And all the projects that will be given to you, then the student will start programming. They will start learning the playground. Then they are permitted to submit between 1st to 7th of December. Okay, and our evaluation and announcement of finalists will be from 8th to 12th of December, and our national finals will be on 30th of January. Okay, so this is the processes, and we still need to emphasize this just for clarity's sake, so that everybody will be carried along. Okay, so each school is supposed to form a team of 5 students with 1 mentor. But if you have lesser students, no problem. But please let it be between 3 to 5 students. Okay, the second step is to join our official WhatsApp group here below in the link. Just click on it. You're going to see link to WhatsApp group. Click on it to join the WhatsApp group. And if you've not registered, the link is also there. So after you have gone through all this series of training for these 5 days, your students will now engage in the playground, and once they are done with their activity or their project, they will record a 2-minute video uncut. What that means is that they're going to record a 2 minutes. You don't need to edit it. You don't need to edit the video. Just record the video, and you're going to introduce the name of your school there, your team name. Each school needs to have a team name, and the team members need to introduce themselves, and they need to state why they are excited about robotics and coding. Okay, so after getting the video, you upload the video in a YouTube or a Google Drive. If you have a YouTube channel, you upload there. But if you don't have a YouTube channel, no problem. Everybody have Gmail. So go to your Google Drive, upload your video there. Then finally, you're going to submit the link to the YouTube or the Google Drive plus the code that the student used in programming the robot. You're going to submit it before 7th of December. Okay, so if you're confused about the submission, you can meet any of the admin. You'll be guided appropriately. Okay, so just to reinforce again, the video is 2-minute video uncut. The code file needs to be there. You need to submit the code as well. And so what you're submitting is a video and your code. These are the 2 things. Okay, so the judging criteria, task completion. When we give you this task, if you complete it, is 40 marks. That's if the robot successfully complete the assigned challenge. You have 40 marks for that. Okay. For coding efficiency, if your code is very efficient, that is clean, is optimized, and it's logical, that's 25%. If for creativity and problem solving, if your approach to the challenge is very creative, then you have 20 mark, and a very good team presentation is 15%. So you should guide yourself while you are preparing for this competition. Make sure you look at these judging criteria to prepare yourself. Okay, so you should also note that each challenge has a maximum score of 100 points. Okay, so points are awarded based on completion, accuracy, and efficiency. But there's going to be penalty for late submission. If you submit your late before this time frame that you have set, you have minus 20 marks. or minus 20 points. And if you have incomplete submission, you have minus 10 points as well. Okay, so we at the end of this training, there's going to be certificate for all participants. So all participants will receive certificates, and there's going to be trophy and medals for top 3 national team in each of these categories. Remember, I told you the elementary, the middle school, and the high school. So you're going to win prizes like laptop, tablets. We have VR kit, which is my favorite. The VR kit is an access, a VIP access to it's worth over $1,000. This VIP it's worth over $1,000 or 900 thereabouts. So we give this the access to the finalists, the top 3 finalists. Okay, so we also have special award that will be given out. Don't bother yourself if you're not part of the first 3. We have also other special award that you can actually look at. First is the Best Code Efficiency Award. So this is different from the previous first 3 finalists. And we have Best Team Spirit Award, and we have the Most Innovative Solution Award. This 3 award will be given to schools based on your performance and based on your engagement on what we are doing. Okay, so the national finalists, the first 3 finals will be on 30th of January 2026. So qualified team will travel to Abuja. We believe that for live in-person final round. Okay, so team face the custom arena challenge. We'll reveal it at the event, and the winner will be crowned at the National VEX Robotics coding competition. Please pay attention to these rules and this guideline that each school may register more than 1 team, but 1 student cannot belong to 2 teams. All code must be original and created during this competition. Team must attend at least 1 online training session before submission. Okay, but most importantly, the educator or the coaches need to attend this online session. Okay, all submission must respect the deadline. We don't want late entries, and all communication must go through our official WhatsApp group. If you're not in an official WhatsApp group, please join. Okay, so this is the training for the 5 days. This document are the sent to our official WhatsApp group. If you're just joining, we're going to send this document again. Okay, so up to this moment, if you have a question, please type your question in the comment section. We have someone dedicated to take all your questions. We're going to address every question at the end of this training. Okay, so if you've not liked our YouTube channel, if you've not shared, if you've not commented, please do so. This helps us to create awareness. This is the goal. We want to create awareness, so please like and subscribe to our channel. Okay, so this is a rundown of what we are about to do. Okay, so next I'm going to be talking about what VEX Robotics is all about. What VEX Robotics is all about. I'm going to be talking about what VEX Robotics is all about. Okay, so some of us are new to VEX Robotics. Some of us are new to VEX Robotics, so I want to introduce us to what VEX Robotics is all about. So VEX Robotics is a global STEM platform that helps students learn engineering, coding, and teamwork through building and programming. Are we selling VEX? No. We just realized that VEX is the largest STEM platform or robotics platform where students can actually learn meaningful robotics. That's why we are using VEX Robotics. I tell you, we have numerous experience in different aspects of robotics. We have experience in different aspects of robotics, but VEX has proven to be the best. Why? Okay, one is that we have the VEX have over 70 countries engaging on it yearly with millions of students. Over 70 countries engage in VEX Robotics, meaning that they go to US every year to participate in the competition. From a document, you see that according to Guinness Book Record, that VEX is the largest robotics gathering in the world. Yes, for students. You can check that out. Okay. Also, another advantage for VEX is that it ranges from primary to university level. All students can do VEX robotics. It's tailored to suit every level of students. Okay, then the last point is that it supports both block programming, either Scratch type that some of us are familiar with, or Python for some of us that want to advance our programming skill. That's why VEX is very good. So VEX has in-class engagement where you just teach your students robotics in the classroom, and they also have the competition aspect where you participate in national competition as well as the world competition. Okay, so the world competition happen in US every year. We have opportune as a company uh, to have first-hand experience in this robotics. We've taken some students to out of Nigeria to US to participate, and we're very happy that we have done very well. In fact, we have won numerous awards. Okay, so this is the VEX ecosystem. We have VEX 1, 2, 3 for students in nursery school and primary school, lower primary. They engage in VEX 1, 2, 3. VEX Go is for students from age 6 to 9. There's a foundation and simple building. We have VEX IQ for students in junior secondary school, VEX ESP and VEX V5 for students in senior secondary, and we have what they call VEX VR, which is what we are doing, what we are concentrating on. It's a virtual robotics for schools that has no physical kits. Okay, so if you want to buy physical kits, you can reach us. We can help you to get physical kits. But if you don't have physical kits, there's no limitation. We have virtual platform where you can also engage students, and that's what we're engaging you with in these 5 days. Okay, so you also note that VEX Robotics is about learning beyond the classroom. It helps you to master STEM-related subjects. I tell you, the best time my students have seen the best of physics, mathematics, chemistry is when they do robotics. Yes, when they do robotics, they tend to see what you when you talk about mechanical advantage, when you talk about gear ratio, is where they tend to understand what you're talking about. When you're teaching them physics, when you're teaching them about waves, they may not understand you just writing it on the board. But when they engage in robotics, it covers every aspect of science, and that's why robotics is good for every student. It also sparkled their critical thinking and innovation skill. So because they will be designing robots that do physical, then they will be able to program and use sensors for those that do virtually. It helps them to think critically on how to solve a problem. And this is the beauty of what we are talking about. It also encourages teamwork. You see that students that work together in robotics always the teamwork spirit is always there. It's always there. So you can't build robots on your own, only you, because there are numerous ideas to a particular solution. There are numerous ideas. There's no one solution to a problem. That's what robotics is all about. You see that you think in a way, other students have another way of providing solution. That's why the beauty comes, and you build confidence in students and expose them globally to compete and connect with peers all over the world. Okay, you as the teacher, what do you tend to gain from this? You're going to gain a fresh, exciting way to teach STEM in your class. Okay, and you align lesson plan and training from VEX Robotics or partner, just like we as the partner for VEX. We're able to arrange curriculum that will align perfectly with your school. Okay, it will also boost your student engagement. The student will love you. There's no any time that you want to engage in robotics that students are done. They love it. They want to do it. It's a way to even to curb bad behaviors from students. It also encourages your professional growth. You have certificate opportunity, and you have the chance to mentor teams and students either in local competition or international competition. Okay, so for students, it exposes them to real world solutions. They become real world problem solvers. So it connects them to real career. It prepares them for career readiness in every aspect of life, in space, in military, in underwater, healthcare, entertainment. security, agriculture, every aspect. Okay, it also prepare them for AI, what they call AI. You're hearing AI everywhere. Robotics is part of the AI. Okay, so for the competition, it also encourages the spirit of competition. Students compete in an exciting annual challenge. Every year, there's robotics competition worldwide that happen in US, but you can't just go just like that. You have to be equipped, you have to be trained, and you have to you have to engage in national competition first. Then, if you win from the national competition, then you cannot participate in the world competition. With this, I'm going to leave you with this our success story that we have experienced numerous success. I've experienced numerous success, and one of it is that we have trained students who competed in the world. I mean people that went to US. As you can see from my screen, we have students from Nigeria who have gone to US, who have participated, and they have done very, very well. They put the map of Nigeria on the global stage, and that is the beauty to build. That you have students that you have trained that build the country over the world. So I also have many African students who also reach the global competition, and we have turned reluctant learner into innovation. I believe that everything I've said so far, we're able to grab everything. But if you have a question, the comment section is where you put your question. At this point, I will allow under facilitator to take over. Thank you very much for coming to join the class. You get your name? You get it? No, no, I don't have. You have the okay.
Hi everyone, thanks for joining us. Thank you for joining us today, and I'm so glad to be on the show today. I thank our previous facilitator who explained deeply the core values of our company and what we are here for. So to take us further, I'll be diving into the VEX Code VR platform, and I'll be explaining how everything works, and we'll be, you know, practicing with a particular playground called the Castle Crasher. So I don't know if you can see my screen. So I'll start from the beginning. So I'll explain everything and how it works. So, and if you can hear me, if you have maybe your laptop with you, or you're following with your tab or something, you can straight up go to vr.vex.com as you can see on the screen. So on first time when you load it up, it brings up an environment like this. Let me start from the beginning. So because I'm sure most of you, when trying to load up the site for the first time, it will show you an environment like, let me start from the beginning and show you how it will come up in your screen if you're loading it up for the first time. Let's wait a minute and see, get it to load up. So it's loading now. Apologies for the delay. Okay, so when you first load the vr.vex.com, this is the screen you would see. So what I want you to do for me is just to click on the students button as you can see on the screen, which I just did, and hence it will bring up a tutorial slide for you. So for the purpose of time and to save time, I'll cancel all these things and dive into what we are here for. So this is the vr.vex.com platform. It's It's an online platform that enables you practice VEX Robotics virtually. So for most of us might not have access to the real VEX Robotics kit. So this is a platform VEX made available for us to come and practice VEX while we, get our hands dirty with real code, even though it's still virtual. So right on our screen, you could see the VR.vex.com platform. So there are various areas here. We see various menus. So I'll be selecting. What I want you to do for me is, if you're following, you go to the select playground. So we'll be practicing with the VEX Code Castle Crasher. When you load up the playgrounds, the blocks playgrounds, you'll see something like this. So what I want you to do is just to scroll down, and you'll see the Castle Crasher right on my screen here. This is it. So I'll click on it and load up the Castle Crasher environment. All right. So while we wait for it to load, so I'll be walking us through on how to get started with the VEX Code VR and a little bit about how it works. So in this session, we'll be coding our virtual robot. So first thing I want us to do, as we've done, is to select our playground, which we've just done, and select the Castle Crasher. So right on the playground, we could see the Castle Crasher screen. So I'll move it here. So right on the screen, there are various things we can do here. So from the view we are seeing now, this is a top-down view. So if you can see this little camera pans around at the edge of the playground. So let me click this pan view to change the view of what we are seeing already. Once you click here, you could see now we're having a closer view. If I want to get an angle shot on the environment, I click on the one that is a little bit slanted. So to get an angle shot. But moving forward now, the best view to have while practicing is the top-down view. All right. So I know for those of us that are new to this platform, will be wondering, what's all this? I'm seeing drivetrain actions. What's all this? So Vex uses I believe some of us might have had experience with Scratch. So if you've had experience with Scratch, you know Scratch is a block-based programming platform. So Vex follows the same principle of block-based programming. And right on our screen, we could see the blocks that we could use to program our virtual robots. So the when started block, it's very simple and practical. Everything we place under the when started block will automatically execute when we start our robots. All right. So I'm going to give us an example. For instance, I'll see. Let's get the robots to drive forward. So everything we place under our when started block, when we execute it, you can simply execute the block-based code when you click on this thing that looks like a play button on the screen. So you could see we got the robot to move. All right. So there are various actions you can take, and I believe most of us know what programming languages mean. All right. So simply, a programming language is a set of instruction or rules where symbol represents actions. All right. In this our case, this block-based programming, the blocks here, they simply represent various actions we can use to instruct our robots to do. Just as I showed us now, I just instructed the robot to drive forward for 200 millimeters, which means I just programmed this robot to move forward for 200 millimeters. So we have various actions we can take and program our robot. We can ask the robot to drive forward. The first action here is the drive forward. Here we need specify drive forward for how many millimeters. If I execute this code, as we can see now, forward forever. It won't stop until it falls off the playground. So the second one, the second one on the screen on the drivetrain actions is the drive forward for 200 millimeters. All right, so it gets the robot to just move for just 200 millimeters and it stops. All right. So the third one on the actions is the turn right, very practical. Just as you can maybe as you're walking straight on the road, you want to turn right. So that's the same way you instruct the robot. Maybe when you've done a particular thing, let's say I've asked the robot to drive forward for 200 millimeters, turn right. So we can also turn right by degrees. All right. We all know the degree of a circle is 360 degrees. So I can ask the robot, when you move forward for 200 millimeters, turn right 90 degrees. All right. Or we can also use the turn to heading. This one is almost the same way as the turn right for 90 degrees, but it works in a different way, whereby in our compass we have the north, the south, the east, and the west. So we all know that the south, the west, or rather the east now is on 90 degrees. So maybe if I'm moving forward, I'd want to turn to 90 degrees heading, which I think is the east. So no matter how my direction have maybe shifted, once I turn to 90 degrees, I must face the north, the east of the compass. All right. So the turn to rotation 90 degrees, you can ask the robot to maybe if you've done a particular action, then you want to turn 90 degrees, you can ask it to turn 360 degrees. So I'll just show us quickly. Let's say I want this robot to just on start turn 360 degrees. So quickly, let's just see how it does. So you could say I got the robot to turn for 360 degrees and it stopped. All right. So we have the stop driving, very practical. As you've been moving, maybe if you own a car, maybe you get to maybe when the traffic light turns red, what you do, you apply the brakes and you stop driving. So the other one, the other drivetrain setting. For some of us that might be wondering what is a drivetrain, let me just quickly show us on the robot what a drivetrain is. So a drivetrain simply it's simply the exactly. So if you can see the tires of this robot now, the tires of this robot, this is the drive train. So maybe you've been hearing me say drive train, drive train, drive train. This is exactly what I mean by drive train. So these are the tires of the robot. Like that's in simple layman's term. All right. So we can set the velocity of the drive train to 50%. Let's say I want to be moving. Maybe maybe I'm driving and there's traffic. I don't want to apply so much speed. So maybe I say, okay, I'll be moving for 50 kilometers per hour. So we can set the drivetrain to move for 50%. That is half of the drive speed. Or we can set it to move for 100%. So subsequently we'll solve this castle crasher challenge. So you'll see how all these things can be applied. So we can set the turn velocity. The last thing I did was I had the robot turn for 360. So if you could remember, it was turning a lot slow. So you could see how slow it was turning. But now I can say, okay, let me set the turn velocity to 100%. The speed did not change. It still turned at the same speed it turned earlier. So that is because the way I place the code blocks, there is order of precedence here. So we have to set the turn velocity first before we actually turn. So before I had the turn velocity to be under. So it will run the turn rotation for 360 degrees before it runs the turn velocity. But that is not how it should be. The turn velocity should actually be set first before the turn by 360. So let's see how it does now. So if I execute this code, you could see it turns a lot faster. So this is to explain to us that yes, programming is about giving instruction, but robots understand instruction as it is being given. If we give the instruction, no matter, even if you know what you want it to do, the order of how you give that instruction matters. All right. So we have the set drive heading to 0 degrees. or maybe that is also the same way, it's practically the same way the turn heading works. All right. So we have the drive rotation and the drive time of, maybe I can ask the robot to drive forward for 2 seconds. All right. So that's it. So we have the values, the drivetrain values. So maybe this can be used in conditional statements. Maybe I can say if drive is done, do this. All right. Or I can say if drive is moving, just as the drivetrain values is showing us, do this. I can say if drive heading is in degrees, do this. So it's the drivetrain values can be used in conditionals. All right. So and we have the magnet on the robot. You mostly use this magnet when you solve challenges like um, maybe when you have to pick up objects and all of that. So you mostly use the magnet. But for this challenge, we will not use this magnet. All right. So we have the drawing. Maybe I want, as the robot is moving, let's just practically do that. So and I want the robot to maybe have like a path, maybe show us the colors that it's, maybe let's see how it works. It's better done than explained. So I'll set, remember the values, the way of at which you set your instruction matters. If I place this set pen to color under here and execute this code, it will not work. So I have to place it at the top here. So I want the pen color to be black. All right. So let's see if that will work. Programming is practical. You give instructions, you try it out. So it didn't work. So why didn't it work? Maybe let's say, okay, let's add this movement down and try it again. So it did still work. The problem is it's working, but we can't see it. All right, because the robot is just moving in 360 degrees. But when we are solving this challenge, I'll use this stuff so we can see how exactly it works. Maybe when I get the robot to move forward. So just not to waste our time, let's keep explaining the drivetrain. So we have the sensing instructions. So we can, just as the human senses are, we have the sense of smell, sense of feelings, and all of that. The robot too can sense its environment using a sensor. All right. What are sensors? The sensors are used to measure physical quantities and converting it into digital quantities. All right. So I can set a sensor. For instance, if I'm building a temperature sensor, I can say, okay, when the temperature of the room I'm in currently is so degree, increase the AC. All right. So that's where we use sensors for. So and the robot too have sensing, and if you can see, we have the sensing bumper. So maybe when the bumper is pressed, just as the same way, if someone pinches you, you react. All right. So we have sensing distance. Maybe when the front distance finds an object, do something. These things are mostly used in conditionals. We have the sensing eye. When you are near an object, perform a particular action. We have the front eye. Well, maybe let's say we want to use, maybe let's say, okay, when you detect red, turn left or stop. All right. So we have sensing location. All these things are used in solving in conditionals, the if-else statement. Right? During the course of this training, we'll get to use all these things. And even if you are new to this thing, trust me, if you follow through, you will get up to speed and you'll be surprised what you can do at the end of this training. These things are practical, they are enjoyable. It's something that the more you do it, it can be addicting sometimes. All right, so we have the console area for the control code blocks. Maybe I can say print VEX code when you've done a particular action. All right. I can say set the cursor to next row. That is going to be used for under training, under challenge. I can say clear all rows. I can say set print precisions to 0.1, set print color to black. All right. So this is where it gets more interesting, the logic. All right. You can, maybe for those of us that have kids at home, you can tell your kid to, okay, go and boil hot water for me. When it boils, maybe make tea. So you just give that child a condition. So looking at the conditions we have here, the logic, you can tell the robot to maybe drive forward. When you detect a red light, wait for 1 second. Or we can tell the robot to wait until bumper is pressed, or wait until you detect a particular color, maybe red in this case, or maybe wait until you detect an object. Keep driving until you detect an object. Or we can use a repeat block, where we say perform a particular action, maybe 10 times, 20 times, two times, depending. Or we can use the forever block, maybe for as you can say maybe for as long as this particular condition is met, do this. All right. We can use the repeat until. We can say, okay, continue driving until you detect an obstacle. All right. We can use the while logic block. We can say while drivetrain is set to 200, continue driving, or while there is no object in front of you, continue driving. We can use the if else, the if then rather. Maybe if let's say, okay, what will I use now? The if no object is being detected, continue driving, then drive. All right. We can use the if then else block. You can see it's more practical. Like it's if this is true, do this, else do this. We can use the if then else if then and else block. Maybe I can say if the color in front of you is blue, turn left. Else if there is red, turn right. Else when the both conditions previously as filled, continue driving. All right. So we have the break. Maybe when I've run the project for I want to cut, I want to stop, I can use the break. All right. Or I can stop the project. All right, guys. So without further ado, let's just see if we can solve this challenge right on our screen. So I'll delete all these things I've set. So to delete it, just quickly, you can easily just drag it outside of the playground, or you can left click and you can just delete block. All right, so we'll practically solve this thing quickly because of our time. So remember when I said everything you set under the when started block will execute when you execute the code. All right, so I just added the drive forward for 200 millimeters, and let's see what happens when I play. So the robot moved for 200 millimeters, but you will notice it didn't get to hit. The aim of this challenge is to crash castles, but it didn't get to hit the castle wanted to crash. So that means the 200 millimeters is too small. So let's say I want to increase it to 800 millimeters and see what happens. So I just asked the robot to drive forward for 800 millimeters. Wow, it just hit one of our castles, but we still have many other castles to go. But I noticed something. I noticed that the speed at which the robot is moving is very slow. Hence, some of the castles still stands. All right, we can see that from here. Some of the castles are still standing. So what do? I can say, okay, let me increase the velocity. Let's say I increase the velocity by 80%. All right. So now let's reset. You know, when you want to reset, you can see that loop back button. You can just click on it to reset. So I play again. Now, wow, it moved at a very higher speed now. All right. So now we just got to crash the first castle. We still have 4 to go. So what do? I drove forward for 800 meters. So what the next thing I will do is I'll add a drive forward block again. But this time you can change from forward to reverse. All right. So I would want to reverse back by the same 800 millimeters that I went forward with. Let's see how it works. So I drove forward for 800 millimeters. I drew exactly. This is what I want. So now I can comfortably. Remember, we talked about the turn right, but I don't want to use the turn right by 90 degrees. Turn right by 90 degrees. I want to use the turn heading because if you are moving as a person and you crash into things, sometimes you get your movement gets to maybe change. But I want to be sure that the robot is turning right to the accurate direction I want it to. And if you look at the playground here, we would see that these castles are set at particular angles. So from where this robot is now, the angle which it's pointed to, the angle which this robot, this house here, this castle here is exactly 90 degrees. So I can ask the robot, when you've crashed the castle in front, turn right by 90 degrees. Let's see how it works. Exactly, turn right by 90 degrees. So I can, from here, I can now move forward. Let's say I move forward for another 800 millimeters. And let's see how it works. I stop the program, I reset, and I move. It crashed it, it turns, moves again, crashed it. Exactly. So I can either want to move off or move again, crashing the one behind it. All right. But I want to go at a particular, I want to use the strategy of edge strategy. So once it crashes it here, so guys, I mean, if you followed me to this point, you know that these things are very practical and easy. So I'll crash another castle, then we'll call it a wrap and move forward. So let me just add another drive forward train block. So crash another castle. So you see how it works. So I drove forward for 200 meters. Then I want to turn back again I want to use the turn heading block. I want to turn back again for 270. If you know your angles well, you know where 270 is, then I drive forward for another 16. Let me say 1600. I wouldn't have time to explain why I'm using 1600, but those of us that are familiar with maths will understand why. So let's see it. I drove forward, turned, crashed it, turned again, then move forward and crash this other one. So guys, we've successfully crashed 3 castles. All right. So there are many other ways you can use to solve this challenge, but this is one of the ways. All right. So during the course of the training, you get yourself exposed to the various tricks around VEX Code VR. So this is where I dropped the baton, and I thank you for joining us today. All right, guys. Take care. See you later. Bye.
Okay, so I hope that this session has been engaging, and I hope that you've learned so much. And this is just the first day, and you've learned so much. You've learned how to crash a castle, and I will also advise that as an educator, as a teacher, you should not just sit behind. Try to engage on the platform at your leisure time. Just find way around it. Play with some of the things that you have not even been shown already. Yes, you can't spoil the, the playground. So play as you want with the playground. Use sensors. There are sensors there. There are sensors that can make your work even more better. Go ahead and use the sensors. So at this point, I'm going to be attending to some questions that have been asked. Okay, so one of the questions was about high school, that if all category should be high school. So we've answered that in the WhatsApp chat. Yes, if you have more than one team, they should belong to different category. Meaning that if elementary, I explained that elementary is the primary school, middle school is the junior secondary, and high school is the senior secondary school. So you may decide to just go for senior secondary school only or team. But if you have any special reservation, you can meet the admin and discuss your concern with the admin, and that will be taken care of. I think I have another question. Okay, about the URL. The URL is vr.vex.com. That's vr.vex.com. It's a web-based platform. You can go to any of your browser, type it in, and you have access to the platform. I hope that this session has been engaging. We want to appreciate each and every one of you that have that find time to engage on this platform. And so I know that you have this schedule, you're a teacher and you're teaching somewhere, but the beauty is that you can multitask as well. So learning, I will encourage us that tomorrow's session is going to be practical or true. So I encourage that you come very early as 10 you are in, and we're not going to be wasting more than your time. Every day is 1 hour. We're not using more than 1 hour. So 1 hour is the time. And I will encourage you, yes, it's a YouTube link. You can watch this later. But it's best when you follow live, because we are usually reluctant as human beings to come back later to watch videos. But when you're there live, you can easily ask a question and you can complete whatever task that's been given. So from tomorrow, please ensure that you join with laptop as well, because using laptop, you can open the platform by the other side and engage what the instructor is teaching you. So we appreciate each and every one of you for coming, for joining us. And if you've not subscribed to our YouTube channel, please subscribe, like our content. We appreciate this because this helps us to create the awareness that we want. And do have a beautiful day. See you tomorrow. Bye. Okay, there's a question. Okay. The question says, okay, so sorry, there's a question. The person say, thank you so much for the training. I want to ask if the coding on VEX VR can control physical robots. Okay, so during the course of this training, you're going to learn all this. You're going to learn all this. Don't worry, our facilitator for the subsequent days will explain to you if this can control the physical robot. But one thing I can tell you is that even though you can control physical robots separately, this same code can be replicated for the physical robots and it's going to work perfectly. Okay, but if you can copy this directly and upload into the physical robot, if that can work, our coach in our subsequent lessons will explain that. Thank you very much for joining us. See you tomorrow. Bye.